Without warning, a small but dangerous electrical short suddenly sparks and ignites inside a high-density data server rack. An IT operator rushes in, grabs a standard CO₂ fire extinguisher, and discharges it to save the equipment. The flames go out almost instantly, and exactly as the label promises, there is absolutely no visible residue left behind on the servers. But while the room looks spotless and the fire is dead, the operator may have caused $1 million in invisible hardware damage. Facility managers and IT teams often rely heavily on that no residue marketing promise. It feels safe because it doesn't leave a mess. When protecting sensitive assets, a clean room does not guarantee you avoided catastrophic secondary damage. To understand why, we have to look at what a Class C fire rating actually means on an extinguisher label. The C rating simply guarantees the extinguishing agent will not conduct electricity. That is there to prevent the person holding the nozzle from being electrocuted. Electricity itself doesn't burn. It acts as the ignition source that sets surrounding materials, like plastic cable jackets or synthetic components, on fire. You typically have 3 choices for fighting these types of fires: dry chemical, often called ABC, CO₂, and modern clean agents. This chart compares the collateral damage profiles of these 3 agents on a corrosion and residue scale. Dry chemicals spikes to the maximum level of damage, while CO₂ and clean agents sit at 0. Fire protection engineers explicitly prohibit dry chemical extinguishers in IT environments. The highly corrosive powder they discharge will ruin entire server racks, eating away at equipment that the fire never even touched. Ruling out dry chemical leaves a high-stakes trade-off: accept the extreme physical properties of CO₂, or pay the premium financial cost for clean agents. The main mechanical risk of deploying CO₂ is a violently rapid drop in localized temperature. Inside the high-pressure cylinder, CO₂ is stored as a liquid. When you squeeze the handle, it escapes and rapidly expands into a gas mixed with solid dry ice particles. This animation shows exactly how extreme that temperature drop is. The discharge plunges the immediate environment to a cryogenic -78 degrees Celsius. This introduces thermal shock. A server contains printed circuit boards made of epoxy resin, copper traces, and ceramic components. Each of these materials has a different coefficient of thermal expansion. When hit with extreme, uneven cooling, the various layers of the circuit board contract at drastically different rates. The resulting internal tension physically shatters microscopic solder joints, cracks semiconductor chips, and delaminates the board. Using CO₂ to save a server rack often destroys the hardware you are trying to protect. Hardware damage is a financial loss, but there is an immediate threat to the operator's life that requires far more attention. A CO₂ system kills a fire by aggressively pushing ambient oxygen out of the room. This mechanism becomes a fatal liability in the specific architectural environments where servers are often kept. Watch what happens to the air in a confined room when a CO₂ extinguisher is fully discharged. This meter starts at a safe 21% oxygen concentration. The meter drops rapidly to 19.5%. Crossing this specific threshold triggers an official OSHA oxygen-deficient hazard. It then plummets below 10%. At this level, physiological effects happen fast: impaired judgment, loss of coordination, unconsciousness, and death within seconds. CO₂ is completely colorless and odorless. An operator will not realize they are suffocating until their motor functions have already failed. In an enclosed closet, CO₂ trades a manageable fire hazard for a highly lethal atmospheric hazard. Beyond extreme cold and suffocation, discharging CO₂ introduces 2 secondary failure modes: tribal electric charging and reignition. The high-velocity flow of dry ice particles through the horn generates massive amounts of static electricity. This can fry adjacent electronics or act as an ignition source for lingering vapors. Because CO₂ dissipates rapidly, deep-seated materials, like dense bundles of server cabling, retain their heat. Once the CO₂ clears and oxygen flows back into the room, they will instantly reignite. This is why modern clean agents, like Novec 1230, were engineered as the premium alternative to CO₂. Instead of freezing the room or aggressively displacing oxygen, clean agents extinguish fires by chemically interrupting the combustion chain reaction and absorbing heat. Neutralizing fires chemically entirely bypasses the extreme thermal shock and lethal asphyxiation hazards of CO₂. We can take this data and map these suppression technologies to specific zones within your building. This architectural floor plan categorizes facility risk zones based on 2 factors: human occupancy and asset vulnerability. In an open office area, clean agents are ideal for safety. CO₂ is acceptable here, but only if personnel are highly trained and the space is well ventilated. For a server room or IT closet, clean agents are absolutely mandatory. This is required to prevent thermal shock to circuit boards and the suffocation of your IT staff. In an unmanned mechanical room, CO₂ remains a highly cost-effective and acceptable choice, provided the equipment is rugged and evacuation protocols are strictly enforced. Selecting a fire extinguisher requires making a precise, room-by-room architectural decision, rather than a blanket purchasing policy. It is worth noting the environmental evolution of these agents. Legacy systems like Halon were highly effective, but were banned under the Montreal Protocol due to severe environmental damage. This graphic shows the high global warming potential and ozone depletion potential of legacy halon on the left, compared to the near-zero impact of modern, eco-friendly clean agents on the right. Modern clean agents require a higher upfront budget. But balancing zero environmental impact with absolute life safety makes them the undeniable standard for critical infrastructure. Carbon dioxide is a powerful suppression tool. However, the introduction of human life, sensitive electronics, and confined spaces forces you to rethink the safety equation. Subscribe to HSEstudy for more authoritative guidance on workplace safety and OSHA compliance.